Hi everyone, I'm Nagaratna. Thanks for joining this course. In this course, I'll be discussing basic concepts of DevOps. We will cover the mentioned agenda in the slide. We will see what is DevOps, why we need DevOps, what is the life cycle of DevOps, what is the difference between Agile and DevOps, what are the different metrics and tools available in the market for DevOps, what is DevOps values and why it is needed, what is fast delivery cycle means, what are the best practices, why DevOps is so popular nowadays, what are the habits of DevOps, what is pipeline, what are the different pipelines available like release pipeline, build pipeline, what is the difference, why we need these pipelines, what is configuration management, what is infrastructure as a code, why these concepts are and the practices are very popular, and what are the pipeline steps, the basic pipeline steps, and the types of testing like regression test, functionality test, non-functional test, load test, the different types of testing available. So we will try to deep dive into each of this topic with examples in coming sessions. I hope you all will enjoy the course, and thank you so much. In this lecture, we will talk about what is DevOps. DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. Here, you have to concentrate on continuous delivery of value. We just don't want to deliver software, we just don't want to deliver something. Whatever we deliver, that is a value that is adding value to our end users. DevOps we cannot buy and install it. Okay, it's like it's not just automation. It's not just a infrastructure as code or having the configuration management. No, it's not DevOps. These all are some of the practices of DevOps, but DevOps is much more than that. It's a people following a process enabled by products to deliver value to our end customers or end users. It's a collaboration between development and operations, IT operations, to make software production and deployment in an automated and repeatable way. DevOps helps to increase the organization's speed to deliver software applications and services. The DevOps word, if you see, it's a combination of development and operations. The main aim of DevOps is to shorten the system development lifecycle and provide continuous delivery with high software quality. If you see everywhere in every line, I am mentioning continuous delivery of value. That's what DevOps is enabling. And DevOps also allows organization to serve their customers better and compete more strongly in the market. In a simple terms, if I say it's an alignment of development and IT team to have better collaboration, better communication, better understanding. And the agenda is to deliver value to our end users. So if you see, it's not just people, it's not just process. It's like people, process, and products are coming together to enable a continuous delivery of value to our end users. So this is what DevOps means. Thank you. Hi everyone. In this lecture, we will see why is DevOps needed. So let's get started. Before DevOps, the development team and the IT operations teams worked completely in isolation. Even the testing and deployment activities were isolated. Moreover, all these activities consumed more time than actual build cycles. So when we do without using DevOps, team members are spending a lot of time on testing, deployment, designing instead of actually building the project or actually building the deliverable value to the customer. Moreover, manual code deployment, staging environment, all these tasks are prone to human errors. It's not only in production, even these errors are more prone in development stage also. As coding team or development team and IT operation team are working isolated way and their timelines are a bit different. Here timeline means the deliverable timelines and there is no sync between them. There is not much collaboration, not much communication. So these all are some major issues which we could see in a system when we are not using DevOps. So what DevOps providing to us? It talks about more about practices, habits, and each practice, each habit will contribute something to the development team and IT operation team. One is predictability. The more you have performing static code analysis, infrastructure as your code, configuration as code, all these practices, you will reduce your failure rate on new releases because the more you automate, your error or human error is going to reduce. The other thing is reproducibility. We need to version everything, your code, documents, database, your firewall systems, your infrastructure. Everything should be version controlled and everything should be maintained as a code and versioned. This will provide you many advantages. Suppose if you want to retrieve something, it's easy to retrieve. You have a end-to-end tracking. You know exactly when and what is released. In worst case, when you have released to production or to your end users, there is some critical issue is noticed, then because you have a version controlled everything, it's easy to restore the system in the production. This what reproducibility means. And maintainability, effortless process of recovery in the event of a new release crashing or disabling the current system. These two are bit interlinked. If you see when there is some crash happened or server is down or server is busy, or there is some unknown thing happening in the system, then it's easy to revert it back and make sure your customers are not affected by that crash or by that server down. There even there we have um, different things which can be considered, something on the maintainability, something on um, um, diverting the traffic between different servers, scale up, scale down. There are many other concepts, so we'll not go into detail of that. The next thing is time to market. It reduces the time to market because whole team is focusing on important and critical activities to make continuous delivery of value. The things which we do regularly or the activities which we do regularly are automated, and you have unit testing in place, your automation in place. So the overall overall development cycle time is going to reduce, and you have reduced your time to market, greater quality. This also help us to improve the quality of application development as it incorporates the infrastructure issues. The more when you have a system which is different in the development, the system which is different in the production, then you have many issues on the configuration, firewall settings. All these are examples, it can be anything. So the more you adapt DevOps practices, habits, then we are going to achieve a greater quality, reduced risk. It helps in reduction of defects across the life cycle. It's not just reducing defects or finding defects at the production stage. In each stage, we are going to reduce the risk. That means reduce the defect rate, because you are adhering to the practices, you are incorporating static code analysis tools, unit test tools, you have moving the test part or all the testing part to left. This is called left shift. We always have to focus to do more things on the left side. That means in the development stage. So we have to achieve the left shift quality, left shift practice. Then this also helps us to have resiliency system or resiliency in the system. The operational state of the software system is more stable, secure, and changes are auditable. That means your whole system is stable. You don't see many major issues. You will not have so much change, or your system is not so different when you have your software or the service in um, production environment, or the staging environment, or the development environment, or it can be quality uh, testing environment. So everywhere your system as a whole is resilient, it is same, it is more stable, it's more secure. While adapting to DevOps, we also have to take care of secure DevOps, and that is again a different concept, which will say every stage of your development and operations should also consider security as an aspect. When you develop a feature or fix a bug, it can be anything, so you have to have that mind, how you improve on the security of your system. When you have something on production and firewall settings, how do you improve and make sure you are securing your system. So even the database, so every step or every activity you do, DevOps has some security aspects also to be considered, so that we'll see later if possible. Then cost efficiency. um, Initially when any organization adapts to DevOps or CI/CD, all this, because it has tools involved, automation involved, the people and the resources are involved, initial cost will be there. But once your system is designed and stabilized, from automation, CI/CD process, static code analysis, unit test coverage, in the um, future, like in coming releases, your cost is going to down. You will reach your time to market soon. You have quality deliverables. You can do the changes, or your life cycle development cycle will be shorter. So it's initially we might have to spend money, time, resources on the tools, configuration and all, but then for the further releases, your system is cost efficient. breaks larger code base into small pieces. DevOps is based on the agile programming method. So these two are also linked, your agile and DevOps. In coming lectures, we will see where exactly these two falls. Therefore, it allows breaking larger code bases into smaller and manageable chunks. So this is also it's like a practice. So because of all these reasons and all these improvements, organizations are moving towards DevOps, its practices and habits, and even DevOps concentrates more on continuous learning and continuous improvement. So I hope this is useful. We will discuss in detail in coming lectures. Thank you. Hi everyone. In this lecture, we will learn about DevOps lifecycle. As you see in this slide, you can see it's two circles, right? So this is like you have to start from plan, then go all through all this create, verify, package, release, configure, monitor, and come back to plan. So this is a infinite loop. The DevOps or aim is to reduce the time to make this whole cycle. We have to be quicker and faster on this cycle. So we have to make the complete life cycle in shorter span. So if you see here, we have two different terminologies, but both of are linked. Even we can use these words interchangeably also. First step in this life cycle is plan. You have to plan what you have to achieve. This is a stage where generally the whole plan to achieve the goal we will do. After planning, you have to create it. Creating means coding, developing. You can call any either way. So you will actually work on the development, work on the features, or fix the bugs, or add a new feature. Those all things will fall into create stage. Once you have create or once you have coded, then generally you will build and test. So that is verify. When you build means in your IDE, once you write something, you will compile, you will see the artifacts. Even in create stage, there are some other habits and practices also need to be included. Example, performing static code analysis or following test driven development approach, integrating your unit test framework. Even that also will happen in create stage or code and build stage. Then you have a verify stage. It means verification, testing. It's like unit test. If you have different uh, types of test included, even that you can do, like integration test is another example. So all this is like verification stage. Then you have a release. To give a release, you need to do the package. Like you will release the software, its release nodes, its artifacts together. So that's a release or packaging stage. Actually, these two are before you release, you have to do the packaging, then give a release. If you have a, web-based application or a different application like web or desktop or firmware embedded application, then your packaging and release process will vary, right? So based on that, you have to package and the release. Then we have to deploy. It is to it will go to production or your next staging environment. There you might have to configure your system, or make more servers to launch this application, or follow green blue deployment. Again, configuration also purely depend on what kind of software you are delivering. If it is web based, then it will go to your server. If you are sharing any exe applications for desktop, then you might have to put in a different server from where customers have to download. If you take a mobile application, then your deployment stage and configuration will vary, like app store or iOS store, right? If it is a firmware application, then you may have a different approach or different set of configuration. So in in the whole life cycle, the habits, concepts are same and applicable for any kind of product. It can be a service, desktop application, or where software, hardware. The main difference will be we have to see how much we can achieve. Maybe as software world is well progressed now, all this happens in the software world. But if we take hardware or embedded applications, then we may not be able to achieve everything in a shorter time. You have to explore things, explore the tools, need to see how much it's possible to achieve. So those things also need to be considered. But in general, this is the whole life cycle. Okay, then you have to configure the monitor. Once you have deployed, you have configured, and it's operating actually in the production environment, or customers are using it, then you have to monitor it. Even in monitor stage also, if it's possible, many software industries, they will completely automate and take the log file, monitor it, monitor the traffic, get some log file, see the use cases, do some analytics. Those things also there. And the different tools which will just give you the configuration part. You just have to configure, and you will be able to monitor it. So you have to monitor this step also, very much important, because if you are not monitoring, you don't know the customer feedback. You will not have a feedback system. Feedback is important, right? Then only you can improve your product, improve your services. You can see what else customers are expecting. If there is a crash happened, or if there is a server down, if we are not monitoring, we don't know what exactly would have happened in the customer premises or in the production environment. So we have to monitor. Once you monitor, you get the feedback. That feedback can be anything. It is a customer is expecting a different UI or user experience, or he is expecting a different feature, or there is some issue, or maybe performance is not good. In you will get different kind of feedback. That is again put into your plan. You will prioritize. Then again we will repeat the cycle. You will develop it, test it, you will package, then you will release it. Then again this loop keeps going. The more you automate, the more you follow these DevOps habits, we will be able to achieve shorter life cycles. I hope you have understood what is DevOps life cycle. We will meet in coming lectures. Thank you. Hi everyone. In this lecture, we will see DevOps and values. So let's get started. Values. If you could recall, in this whole course, we were focusing on continuous delivery of a value. What does it mean? Value means when you deliver something, to customer should be happy. He should be able to use it. Customer should buy. Then only you will have the return on investment. You will improve your cost uh, or profit, right? You will improve on the profit. So DevOps focus more on like how do we improve product delivery to our customers. This is the main focus, how to make customers happy so that they can buy our products and we can make a profit and return on investment. How do we change product more quickly to better satisfy our customer? You have released a feature to customer, but customer didn't like. He wanted the feature in a different way, or he needed a different user experience. Okay, then we cannot hold the customer like now I cannot give, it will take 6 more months to deliver what you have asked, right? Because customers will not be happy when you say no, I'm going to take a year or 6 months to release what you are expecting. So it says like how do we change product more quickly. If you could recall again, we focused more on automation, continuous integration, continuous deployment practices. When you have all of this, then we will be able to change our product and services more quickly. Even it focus on how do we recover after failing our customers. Suppose there is a software crash happened or server is down or there is a huge issue found in the software which you have released. Okay, now how do we recover? Because in software world your requirements changes, your customer need might change, your technology is changing, everything is evolving. So if you take 2 3 years to develop a product on current technology, in the 2 3 years time your technology will change. Your competitors may come up with products quickly. That means you are going to lose your customers and your technology might change. Customer requirement also will change. That's because of all this, we want to release the softwares more quickly, and even if we fails, we have to recover from it. How do we get paid faster by our customer? Why we are doing all of this, right? It's to have profits, retain our customers, gain more customers, then you have to get paid from the customer. Then that means you need to have profits, increase your return on investment. Then you have to retain your customers, right? So DevOps and DevOps values focus more on customers, how to satisfy our customers by giving a greater quality products and services, and how to retain them, how to make change more faster, more quickly, right? So this for DevOps focus and it values. Thank you. Hi all, welcome back. In today's lecture, we will see about the tools. If you know this continuous integration, continuous deployment, or continuous monitoring, there are many different tools available. In this slide, some of the tools I have captured, like Git, Jenkins. Jenkins is a build automation server. Selenium. Selenium is a test automation framework. Docker, again, this is a server. Then you have Puppet, Chef, Ansible, Visual Studio, PagerDuty, Terraform, Chef, JFrog. This is again a artifactory management tool. We have Salt, Slack, AWS. This is a cloud solution. Then you have Bitbucket. This is a version control system. Like this, there are many tools available in the market based on your need, based on your complete ecosystem, like what programming language you're using, what is your integrated development environment, Eclipse or True Studio, STM based, or IAR Workbench, or Visual Studio. So, based on that, and your unit test framework, whether you are using Seedlink, Google Test, or JUnit for Java, even how you want to monitor, whether it's a um, web-based application, then you have a different set of tools you have to use. If it is a desktop application, then maybe live monitoring or getting the log on live to the cloud may be tough, or there might be some security concerns. Then how you are maintaining your pipeline, whether you have um, YML files or GUI based. What are the stages involved in your continuous integration and your continuous deployment? Based on many factors, you have to be chosen the tools which you want to integrate. If it is embedded, then you might have a different set of unit test framework or automation framework to be chosen. If it is a desktop application, then you might have a different example, Cucumber or Selenium automation tool. So, based on your requirement and what you want to achieve, we have to choose those tools and have to integrate all these tools uh, to get your continuous integration or continuous deployment. Thank you. Hi everyone, hope you are enjoying the course. In this lecture, we will see why DevOps is so popular. DevOps helps to achieve shorter development cycles. It reduces implementation failures. When you want to do some experimentations or some hypothesis driven development, DevOps helps the team to achieve that. It helps to have better communication, better collaboration, more cooperation among all the teams, which includes development team, IT operations teams. Thank you. Hi all. In this lecture, we will see about metrics. Let's get started. There are different metrics available, and these metrics will uh, vary, or it will depend on the or your requirement and what you want to measure. So these mentioned metrics in the slide are some examples, but it purely depends on what you want to measure and what you want to have as a feedback, so that you can have continuous improvement on your process and on your products. Deployment frequency, generally when you don't have automation, when you are not having CI/CD process, then the time taken to release that particular feature edition will take more time, because everything is manual. You have to do manual testing, you have to manually deploy. So the deployment frequency is very less. The more you automate, the more you have continuous integration, continuous deployment, your deployment frequency is more. That means you will be able to release more frequently. Then change lead time, change failure rate. You can measure how much time it is taking to release it and how much time you are totally consuming the moment you get the requirement to the time which you give to the which you release to the customer. So the complete time, the lead time also we can see. Then change failure rate. The more you automate, the more you have configuration management, version control in your system, you will be able to reduce your failure rate in new releases. You will not have many bugs identified at the production because you are following unit testing and code analysis, dynamic code analysis, software composition analysis, and other practices. So you will be able to improve the quality and your failure rate will decrease. Then mean time to recover, shortly MTTR. This is the mean time to restore the system or product when there is a failure. This includes any outrage or server is down. So a server crash or software crash can be anything. What it says, how much time we are taking to recover from a failure. So this is mean time to recover. When you have version controlled everything, your artifacts, your code, your documents, your configuration management, your infrastructure, then even when there is a failure happened, you will be able to recover quickly and reduce your overall effect on the system. Other than these metrics, there can be many other metrics we can do. Example, you can see how much you are improving on your unit test coverage, or how many critical bugs are noticed in a sprint, or how much automation coverage you have achieved, or if you are performing sonar cloud or static code analysis, then you can even measure how much you are improving on the quality. So like this, there might be other metrics also which you can measure, and these measures or metrics are purely depend on your need and what you want to measure, so that we can improve as a team, we can improve the process so that we can make our customers happy by delivering a quality product. And we have to focus on achieving continuous delivery of value to the customers. Thank you. Hi all, welcome back. In this lecture, we will see DevOps practices. There are 7 practices which DevOps suggest. So let's get started. As you see here, we have configuration management, release management, continuous integration, continuous deployment, infrastructure as code, test automation, and application performance monitoring. These are the 7 practices available from DevOps. Okay, let's see one by one. Continuous integration. What does it mean? In any organization, when we are working on a product, or in most of the organizations, right? When we are working on a product or service, many developers get involved. One developer will be developing X feature, one more developer will be developing Y feature, and if we are maintaining our code in version control systems like GitHub or Azure DevOps, then we all will have our own branch to feature branch, right? To develop the feature, and you will have a develop branch where your code will be integrated. So, in continuous integration, we need to automate the merging of the new features to the existing working software. To automate this, there is something called pipelines. Okay, in that it includes building the project, unit testing the product, means it's a TDD approach again, not manual unit test. Then if you have integrated static code analysis, that also should happen. This complete build, unit test, static code analysis, merging the code to the develop branch, all this is steps called continuous integration. This also should be faster. It will be faster when you have automated the whole steps. Now let's see infrastructure as a code. What does that mean? Okay, now you have developed a software. Take any web software you have done and you have put that in the server. This also will have lot of configuration, maybe HTTP port settings, firewall settings, or any Windows environment, so that it will have some JDK dependencies or Python dependencies altogether. So you are developing in your PC, you tested it, it's working. The moment you give to QA or production, it doesn't work because your infrastructure is different. We don't know what is maintained or what is infrastructure in production or in the staging environment. In your local, also it is a different. The IT operation team, they doesn't know. When you are writing a feature, maybe um, because that feature need some upgraded JDK version, then you would have installed and you're working. But that info is not there or not known to the IT operations team. And this is a typical example I'm giving. Most of the times we get complaints like, in my PC it works. That's what developer says, and in production or in IT operations team they say it doesn't work for me. You don't even consider that there is even between two developers also we might see these issues. In my PC it works, but in another developer PC doesn't work. So these all typical issues come when we don't focus on infrastructure. So infrastructure also need to be maintained as a code. If someone needs the infrastructure, you just share your Docker image file or configuration management code. Then the similar setup is replicated n number of times. Okay, so DevOps says your infrastructure also should be maintained as a code. Even your database also should be maintained as a code. Then this infrastructure have some configuration, maybe firewall settings, port settings, etc. That also should be maintained as a code. So that's what configuration management says. So your infrastructure and its configurations also should be version controlled and maintained as code. Next is test automation. This focus on automating everything, your unit testing, integration test, performance test, functional test, UI test, load test. To possible extent, we need to automate everything. The next one is release management. How you are releasing? Are you sharing in email the artifacts? How we are sharing? Are you sharing through emails or messages, or you are using a JFrog Artifactory or Azure artifacts? So how you are managing your releases? How you are managing your versions so that when there is a server down or there is a issue noticed in the production, you will be able to recover from it quickly. The next one is continuous deployment. Once the development is done and all other steps are done, it has to go to the customer. It need to be deployed. Otherwise, we don't get the feedback, right? Just keeping all the features developed in developer PC alone doesn't help. It has to go to continuous deployment. That means it should go to customers. You get the feedback. So this is another practice. Application performance monitoring. Once development is done, it's been released to production. Customers are using it. But if we don't monitor, if we don't see how customers are using it, how the tool or the service is performing in the customer premises, then we cannot improve. That's why even after releasing it, we have to monitor it, get the feedback. Based on feedback, again we will plan or update the requirements or update the features and do the all this process again. This is application performance monitoring. All these are as much as important. In this, nothing you can, no practice, we can just leave. Maybe we may not be able to do everything at a time, but we have to slowly progress and work on all of these practices together to achieve the continuous delivery of value. Thank you. Hi everyone, welcome back. In this lecture, we will talk about DevOps habits. Let's get started. Similar to DevOps practices, we have 7 habits: life cycle culture, hypothesis driven development, focus on flow of customer value, evidence gathered in production, manage infrastructure as a flexible resource, rigorous management of technical debt, team autonomy, and enterprise alignment. Let's see all of this in coming slides. Team autonomy and enterprise alignment. We, we all have common backlogs and self-driven Scrum teams. All teams are self-organizing and we follow 4+4 planning. This mainly focus on how the development team is there and its enterprise alignment with the objectives. The next one is rigorous management of technical debt. How we are managing the technical debt. Continuous monitoring of development. Even in your development stage also we have to monitor how we are performing, how we are developing. Identify technical debt. We have to identify if there are any bugs or any architectural issues. To identify that, we need to have more reviews, peer reviews. we should have static code analysis integrated to identify the technical debt. We have to focus to get minimum number of bugs so that we actually improve on the quality and reduce our technical debt. Next one is focus on the flow of customer value. We have to focus on customer value and it should be continuous. Practice of updating and maintaining production server. You have to maintain all your configurations as code and make sure you're updating your production servers. Observe what get used, what doesn't get used. When you have released a feature to customer and if customers are not using it and they're not happy with the feature which we provided, then we have to improve on that, right? That can be done when you monitor it and get the feedback. Look at high usage account, which features are being used more frequently so that you can improve your algorithm or user experience, or maybe we can do some analytics, right? So we have to focus on the flow of customer value. Hypothesis driven development. In all software developments, we all do some experiments. We will assume few things, right? Then we have to experiment, we have to validate our experiments and make sure our hypothesis is correct or disprove that. Otherwise, we don't know. We will be in still assumptions which will cause more effect. Delivers a measurable conclusion and enables continuous learning. The more you experiment and make sure you disprove your hypothesis, that means you are continuously learning and improving. Also, we need to enable continuous key feedback from the stakeholders. The next habit is evidence gathered in production. To gather evidence in production, you have to monitor it. You need to have logs available. We have to see what went right, what went wrong, how the performance of the system is. We have to measure the performance. Then only we will be able to identify and find the root cause and address it. Life site culture. We always have to think whatever I'm developing now, it should go to the site or field. Customer has to use it. That live site culture mindset has to come. Then if there is any issue noticed, we have to quickly fix it. We need to do root cause analysis. So the mindset should be always live site culture. Infrastructure as a flexible resource. We have to manage our infrastructure and its configuration as a code and version controlled. So if you could notice, the practices and these habits all are interlinked. If we see evidence gathered in production, the practice is application monitoring. You have to monitor your application performance, right? Even the release management, infrastructure as a code, configuration management, these and all comes linked to infrastructure as a flexible resource. So both 7 habits and 7 practices are interlinked. I hope this has given you more clarity on the DevOps habits and its practices. If you have any doubts or anything is not clear, please reach out. Thank you. Hi all, welcome back. In today's lecture, we will see what is the difference between DevOps and Agile, or how the DevOps and Agile are interrelated. So let's get started. DevOps. As we have seen in previous lectures, DevOps enables rapid deployment of products or services. DevOps is a culture deploying to production in a faster and automated way. DevOps suggests we have to deploy to production. The mindset should be like um, the product or the service which we work has to go to production. We need to get the feedback, and that too it should be in a automated way and faster. It's a software development method which focuses on communication, integration, and collaboration between development team and IT operation team. This was DevOps is. Now let's see what is Agile. Agile involves continuous iteration of development and testing in the SDLC process. It's an iterative, incremental, and evolutionary development. It breaks the product into smaller pieces and integrates them for final testing. If you have seen in Agile also we have different frameworks. Actually Agile is a philosophy. It has Scrum, Kanban, Extreme Programming, DSM. Like that there are many different um, frameworks available under Agile umbrella. So Agile concentrates more on how you develop software development lifecycle process, and it says we should develop, build, test it, then do the cycle again. And it has different frameworks as I already mentioned. But Agile is a philosophy and it focuses on development side, development team side. So this is DevOps and Agile on high level. Next slide, I will show you more detail about it. If you see here, we have a customer plus software requirement because we get the requirement from the customer. Then you have a developing and testing stage. It's a developer plus tester. So this is a development team. Then you have operations plus IT infrastructure. So there is a gap between requirement and the development team. This gap is filled by agile methodology or agile philosophy. So this is the solution for this. And agile development involves a set of practices like agile scrum, agile kanban, etc. So agile concentrates more on the requirement and the development, how the communication, collaboration, feedback is captured or addressed here. Then we have development team and operations team. There is a gap between both of the teams. So this gap we need to address, that has been addressed by DevOps. So DevOps involves a set of technical processes such as continuous development, continuous integration, continuous testing, continuous deployment, continuous monitoring, infrastructure as a code, configuration management, automation. The different set of technical practices, habits has been provided by DevOps, which will further address the gap between the development team and IT operation team. So let's see the difference between Agile and DevOps. Agile purpose is it helps to manage complex projects. Generally, we have different types of projects, complex projects, obvious projects, complicated projects, like that. So complex projects means everything is unknown, your problem is unknown, your solution also unknown, and the requirement and the solution comes the more you move, the more you develop, the requirement clarity will be evolved. So that's what complex project means. Then here the target area is software development. In Agile, it offers shorter development cycle and improved defect detection. When developing software is inherent to Agile, mainly organizations do their software development using the agile philosophy or agile methodologies. It focuses on functional and non-functional readiness. It does focus on both. Agile doesn't emphasize an automation, though it helps. Actually, automation is coming from DevOps, but Agile doesn't emphasize. But once you have the automation and other practices, it helps. It helps to have a continuous delivery of a value. In Agile, feedback is mostly given by customers. Now let's see about DevOps. It's a central concept is to manage end-to-end engineering process. It's not only development, it's like end-to-end process management, end-to-end business solutions and fast delivery. DevOps focus more on faster delivery cycles, and that cycle, as last lecture we have seen that DevOps life cycle, you have a build, release, monitor, plan. So all that stages should be faster and faster. We have to improve on that continuous loop. Supports release cycle also. This is not just development, it even supports the release cycle, deployment, production, staging environments. It supports end to end process. Developing, testing, and implementation all are equally important. Okay, it's not just development because agile focuses more on development, but DevOps says everything is equally important and we need to automate the most of the activities. It focuses more on operational and business readiness. If you have seen anything like a development team has developed some product, but if it is not going to market or if it is not giving feedback from the customers, then we don't know whether we are producing the right product or not, right service or not. So feedback is always important. To get feedback, we should be having a build process in a very faster manner. Otherwise, you don't get the feedback quicker. Even we cannot have hypothesis driven development or experimentations, because when you want to try out something whether customer is going to like it or not, you have to be very quick, you have to be very faster, and based on feedback you have to emphasize on your design and development. So automation is a primary goal of DevOps. It is not just for testing. Every step involved, like from the requirement to production and going to customer, from customer getting feedback, the complete activities should be automated. It's not just only testing. Okay, it's not like you have to automate only the testing, but you have to automate your CI process, integration process. In testing also we have different types of testing: unit testing, integration testing, user acceptance testing, even infrastructure when you have to load to the server, if you have to scale up or scale down based on the traffic. All these also should be automated. That's what primary goal of DevOps is: automation. It works on the principle to maximize efficiency when deploying software. So the more you automate, the more you are quicker, your customers are happy, right? So and you will have more return on investment. You are not wasting resources time, you are reducing your waste. That means you are having lean management. So automation is the important and primary goal for DevOps. Feedback is mostly measured by the internal team by using continuous monitoring tools. That's what, if you see, DevOps says everything is continuous integration. You are integrating your code on regular basis, you are continuously monitoring, you are continuously improving on your process, tools, quality. you are doing continuous testing. So everything is continuous in DevOps. So I hope this has given you some kind of clarity where Agile falls, where DevOps falls. If you could recall here in this cycle, DevOps falls mainly on complete cycle, but Agile is concentrated more on software development. That means here plan, create, verify, package stage, or you can even say code, build, test this stage. So in this first half circle, your Agile focuses, but DevOps focuses on complete collaboration, complete development team, and IT operations team. So again, just to recall, DevOps says you have to union the people, process, and the tools and the products to make a continuous delivery of a value to your end customers. I hope this has given you more clarity, and thank you. We will see you in next lecture. Hi everyone, welcome back. In this lecture, we will see what is first delivery cycles. So let's get started. As you see in the screen, we have two charts or two graphs. Okay, x-axis is time, y-axis is change. Before DevOps or before Agile has evolved, we take so much time to do a change. We'll take a long time to do any change. Change includes a new feature addition or upgrading or improvement on the existing feature, or even it can be a new fix or bug fix, right? So we take so much time to do the change, and it will have lots of lines of code. If you notice, what is the problem by having a lots of lines of code, right? Generally every software has that, but the more you take time to develop, the more you write number of lines of code, the risk involved is more, because you are just writing your code, you're not getting feedback from customer, you're not deploying it, you're not releasing it, you're not um, focusing on customer need, you're just writing a lots of code. Maybe you might do unit test, right? The risk is increasing. We don't know after taking this much time. Suppose one feature addition you are doing and we have taken 6 months time to do that. Once it went to market or once you release that to customer would have expected a different feature, or now he doesn't need that feature because technology has evolved, or he would have got the same product and the same with the same feature somewhere else, right? Then customers are unhappy, that means we are unhappy, organization is unhappy. So from this, even this is similar to waterfall, okay, where you will just write the code, design only, design, then you take 6 months to test it, then you take some more 6 months to get feedback, then you take almost 2 to 3 years to develop a product without getting any feedback from the customers. So there is a huge risk there involved. From that mindset, or from this way of working, to faster delivery cycles. DevOps guides us. You have same time, same number of changes, but it says focus on small amount of code change and deploy frequently. The more you deploy, the more we get the feedback from the customers. We reduce our risk, we reduce our assumptions, we also reduce the experimentation part because you're doing more quickly. You're just implementing a small feature, deliver it, get the feedback. If this is what customer need is, then on top of that you write one more feature again, deploy it, get the feedback. So this loop goes continuously, and if you could notice, your delivery cycle is going faster. The faster you deliver, the faster you get feedback, we will be able to achieve continuous delivery of value which customer wants. So this is what fast delivery cycle means, and DevOps and it practices, habits, all of this help organizations to move towards faster delivery cycles. Thank you. Hi everyone, welcome back. In this lecture, we will see the difference between continuous delivery and continuous deployment. What is continuous delivery? It also automates the delivery stage or delivery phase. Continuous delivery is a software development practice where you build software in such a way that the software can be released to the production at any time. That means whatever you have developed, it is ready to be released, but it's not automatically deployed to the production. In continuous delivery, manually we need to deploy it to production based on the need of business or increasing the quality and velocity of the product. So each and every change is not deployed to the production. Manually we have to deploy it. That is called continuous delivery. Let's see what is continuous deployment. Continuous deployment means that every change that we make goes through the pipeline, and if all the test cases passes, it automatically gets deployed into the production. So with this approach, the quality of the software release completely depends on the quality of the test suite, as everything is automated. Here we don't have to deploy manually. Once the test case passes, once the metric quality gate is cleared, the software is automatically deployed to the production. In both of the terminology, whether it's a continuous delivery or continuous deployment, the software is ready to be released. The change between this is it's not automated in continuous delivery. In continuous deployment, everything is automated. Once everything get passed, then it is deployed to the production. Thank you. Hi everyone, welcome back. In this lecture, we will try to understand what is pipeline, why we need pipeline, and what are the different pipelines available. So let's get started. What is a pipeline? It's a key practice in DevOps. Okay, we have continuous integration and continuous deployment. These are the two key practices. So pipeline is supporting CI/CD. Pipeline is where the environment have different stages. You have development, coding stage, build, unit testing, static code analysis, user acceptance test, field test, production. There are many stages available. So all these stages put together in a pipeline. And most of the manual things are automated. so that developers can achieve high code quality, flexibility, and make numerous deployments. There are two different pipelines available: build pipeline, release pipeline. Build pipeline supports continuous integration, release pipeline supports continuous delivery or continuous deployment. In a CI/CD pipeline, it mainly focuses on how to automate the commit stage, build, static code analysis, software composition analysis, all these other stages. Why we need pipeline, or why to create a pipeline? A pipeline code defines your entire build process, which typically include many stages. Example, building an application, testing it, performing code analysis, performing software composition analysis, delivering it, etc. So we are making sure all these stages are defined in the process through a pipeline. DevOps is maximum automation in a software development lifecycle. So we have to maximize the automation so that as a team we all can focus on delivering value to our end users. Pipeline helps in achieving this and keeping track of software releases. So when you have a pipeline, we will have more versioning, more control over the software releases. Thank you. Hi everyone. Let's continue our discussion on pipelines. As we have seen in previous lecture, we have two different pipelines. One is build pipeline and release pipeline. Each pipeline will have stages. In this slide, as you see, development team or delivery team will work on some feature or deliver some software. Develop some software. Then you have a version control stage. Then you have build and unit test stage, automated acceptance test, user acceptance test or UAT, then release. In build pipeline, version control, build and unit test are part of it. Then next three, release, user acceptance test, and automated acceptance test are part of release pipeline. We see once delivery team has check-in to the version control, this will trigger my build pipeline, in which you will have a build, unit test, static code analysis, and other stages. Once it is triggered, if all these test stages are passed, then it will go for next stage. If there is a fail happened, either in a build or unit test is failing, or static code analysis is failed, then this will give a feedback to the delivery team. So every stage has to be passed so that it will go to the next stage. Whenever there is a failure happened in any of the stage, that is given as a feedback to the delivery team. So once everything is passed, that means all stages are passed and approved, then it will go for a release. It can be through continuous delivery or continuous deployment. If everything is automated, this will be published and available for users, or else this particular release is ready for production. Only bit manual work is involved so that it can be released to the customer. Now let's see in detail about steps involved in build pipeline. Version control. All the source code has to be part of version control system. Otherwise, multiple developers cannot work on the same source. A lot of manual work and more prone to human errors if we are not using version control systems. When a commit to the source branch is made, first stage of the build pipeline is triggered. Then you have unit and integration test stage. So in this stage, you will have some framework integrated for unit testing. Then you will write unit test and individual features are developed and tested. Then next one is integration test. When we integrate one or more features, more than one feature together, and it is tested through TDD approach, then it is called integration test. So in the build pipeline only your unit test and integration test will execute. Then you have a build step. In build step, we will build the code because we have to see whether your project is compiling and building or not. If all these steps are executed successfully, then the executables are stored into artifact repository for later use. These artifact task can be anything. If you are using Azure DevOps, then you will have a build artifact and we will store these artifacts in Azure artifacts. Along with these basic steps like building and publishing artifacts, we will also have static code analysis, unit test execution, integration test framework execution, generating a code coverage report, generating a test coverage report of unit test. All these also part of your build pipeline. Thank you. Hi everyone. Let's continue our discussion on release pipeline. We have seen what is release pipeline. After your build pipeline is succeeded, the artifacts from build pipeline has been taken and deployed into staging environment or user acceptance environment, or it can be a QA environment where build pipeline artifacts are tested. So this can vary dependent on your um, type of application. If it is web based, desktop based, or firmware based, etc. So first stage can be automated acceptance test. Acceptance testing is a process of running a series of tests over your compiled or built code to test against the predefined acceptance criteria set by the business. So from build pipeline, you will get the artifacts. Those artifacts are tested against some acceptance criteria which is defined by your product owner or by business. So this is automated acceptance test. Then you will have user acceptance test during a UAT. Shortly, it can be called as UAT, user acceptance test. Users test the software to make sure it can handle required tasks in real world scenarios according to the specifications. These two are typical examples mentioned here. Along with this, even you can have many other stages in release pipeline like approvals, quality gate check status. Suppose you are doing sonar cloud analysis or static code analysis or clockwork analysis, then you can generate a report and set the guidelines. Like if this is passed, then only it should be deployed to the release pipeline or to the customer. Then you also can have some more metrics to see how much test coverage it has. And if you take example of desktop application, for desktop application we cannot deploy in web, right? You have to install that in some PC or in some Microsoft hosted agent or in the cloud. So that time you need to write some more steps like taking these artifacts. If it is a zip file, then it has to be extracted and install that application, desktop application in a PC. After that, you can run some UI test, automated UI test. So then you have a different framework. If we have some controller software, say some controller software, then there is a need of having software in loop or hardware in loop. Then you might have to flash that firmware or that controller software to some controller. Then you might have to do some connections, so there is bit manual work is involved. If it is a controller software, then you can have a different framework for automation, say NI stand or lab view or robot framework, right? So based on your application, release pipeline also will have different stages. If we take lab view for our controller software, then lab view has to be triggered, it has to be linked, what test case it has to execute, it has to publish the result back to your pipeline. So these and all also part of your release pipeline. And thank you. Hi everyone, welcome back. In this lecture, we will see types of testing. Majorly, we can classify testing into two types: functional testing, non functional testing. What is functional testing? Feeding a specific input and examining the output. Like you have a specific input to be given and you expect specific output or behavior. Functional testing is conducted to evaluate the compliance of a system or component with specified functional requirements. Generally, when we develop any software or any service, you will have some requirements. It can be technical requirements, functional requirement, performance requirements, etc. So we evaluate the system or the component with respect to those specifications and the requirement. Testers do not necessarily need to know how the software has been implemented. They doesn't want to know the logic inside what you have written or what developers are written. The main focus for testers to test the application and see whether the software is meeting the requirements or not, which are specified by the business or product owner. That is functional testing. Non functional testing. In non functional testing, test we test the software for the way it operates. We don't see about any specific requirement, but non-functional test we focus more on performance, security, reliability testing, load testing, etc. So this is the major classification we have on testing. Thank you. Hi, all. Let's continue our discussion on testing. In functional testing, there are different types are available. Example, smoke test. Smoke test means test the most important functionality of a component or system. Identify main issues of the functionality. So, smoke test more focus on important functionality of a component or system. Generally, whenever we go for a release, we prefer to do more on regression test. Smoke test or sanity test generally happens when you have developed a small feature or did a bug fix. Then we perform smoke test or sanity test. Now let's see what is sanity test. The need of sanity test is to rule out certain obvious false results, not to catch every possible error. Suppose now I have updated a version and I have given the release. Other than version update, developer hasn't done much changes on the software. So when we give a release, minimum we need to see whether we are able to install the software. That is like minimum thing. So this can be called a sanity test. Yeah. Mm. If you have done a bug fix, then we will test the bug, right, whether it is working or not. That can be considered as a smoke test also. Okay, so this is like based on your need, what you want to test. That particular testing falls under a different category, regression test. This is like whenever we have to go for a release to customer, the regression test we do, it's like we test the product or the service in an extensive way, repeatable and automated testing of the entire software. We try to automate most of the test cases and the functional test, and this is repeatable, and we will do the test extensively so that whatever new features or bug fixes implemented are not affecting the existing application and existing functionality. So this is called regression testing. Hi all, let's continue our discussion on functional and non-functional testing. Let's get started. Non-functional testing also has different types of testing. Example, load test, performance testing, security testing. What is load testing? Process of putting demand on a system and measuring its response. So you have a server and many customers will access the server. So we have to test by putting so much traffic on it and see how the system is responding. Next one is performance testing. How a system performs in terms of responsiveness and stability under a workload. Whether is it slow when you're requesting some data, how quickly it is loading, or is it taking so much time, how the system is stable when I'm performing multiple operations on it. So these type of test cases comes under performance testing. Then we have security testing. Determine that the data and resource of the system are protected from possible intruders. So this focus on more on the security, whether are we storing any sensitive data which can be easily accessible or not. Are we logging some sensitive data in the log files which software generates? Are you authorizing the users or not? Are we authenticating and checking the user validity or not? And suppose you have done you have forgot the password and you tried multiple times, and in that scenario how your system is designed, any third party or any intruder or hacker can snip into your data and access the data or not. So these kind of specific aspects of data and the security has been considered as part of security testing. Even the testing types and varieties also depends on your application. If it is web based, you might have different scenarios of testing. If it is controller software, then it is different. Even in controller software, if you are using wide communication or wireless communication such as Bluetooth, then you have a different scenarios to be tested under functional and non-functional testing. So it depends on our system and the target users. I hope this has given you some idea of testing. And if you have any doubts or if you need some more topics to be covered, please feel free to suggest. Thank you. Hi everyone. Thank you so much for enrolling to the course. I hope you have learned something new, and the concepts discussed in this course has clarified your doubts. If you have any doubts or you want me to cover specific topics in a different way, please feel free to suggest me in the chat, or you can reach me on my mail so that I can try to cover those topics also as part of this. And please, this PPT I have attached into this resource section. You can download and have a look on it. And please also check out my other courses on Sonar Cloud. Thank you again for joining me into this course.